Hello, so we are going to be solving this problem, an interesting one. Again, points of intersection. Quadratic equation y equals to x squared intersects with a straight line having a gradient of half and passing through the origin. Find the points of intersection. Absolutely simple problem, no big deal. Okay, so what we have here is we have a parabola which goes through the origin, which is an upright u parabola. Y is equals to x squared, and then we have another straight line which has a gradient of half. So therefore it's slightly shallow and it passes through the origin, so that's our origin. So we're gonna find out the point of intersection of these two points, so point A and point B. Okay, so that is x plus and that's y plus, and we have our origin. So first and foremost, let's find the equation of this curve. This curve is going to be y is equals to half x. Okay, there is no c because the y-intercept is 0 because the line passes through the origin. So we have the two equations, y is equals to x squared and y is equals to x by 2. Very simple. So what we then do is we then substitute the value of y from the second equation into the first equation. So you're going to have x squared is equals to x by 2, or in other words you're going to get 2x squared is equals to x, or in other words you're going to get 2x squared minus x is equals to 0. So or in other words you're going to have 2x squared minus x plus 0 is equals to 0. So we then have it in the ax squared plus bx plus c form. The roots of this equation are minus b plus or minus b squared minus 4ac divided by 2a. So therefore this is minus b is plus b plus 1 now, because b here is minus 1 and a is 2 and c is 0. Now plus or minus square root of b squared is going to be 1 minus 0 divided by 2 times a is 2 times 2 is, which is 4. So we then have 1 plus or minus 1 plus or minus 1 by 4. This means either the two numbers are it has to be 0 and it has to be how much 2 by 4, which is 1 by 2. So you have two numbers of 2 points of intersection. So at x is equals to 0 and at x is equals to half. Let's find the corresponding values of y. So we then have the simple equation y is equals to x plus 2. We substitute what happens, we see what happens to this at x is equals to 0. At x is equals to 0, y is 0. Pretty simple. And we also see what's going to happen to this equation at x is equals to half. So this is again y is equals to half of half is 1 by 2 by 2, which is 1 by 4. Okay, so which is 1 by, okay, so not responding. Let's refresh. Okay, so 2 by 2, which is 1 by 4. So there we have it. So we have 2 points of intersection, and the 2 points of intersection are point A, which is 0 comma 0, this is this, and point B, which is half comma 1 by 4. Okay, so this is this point. So A is 0 comma 0 and B is half comma 1 by 4. Okay, isn't that nice? It's just spectacular. All right, let's have a look at the next problem. Identify the points of intersection of this parabola y is equals to x minus 2 times x minus 3 with the x-axis and the y-axis. Okay, all right. Okay, I'm not really sure how the parabola looks like, but let's have a look. But if I were to have something like if I were to equate this parabola to 0, okay, so let's say that x minus 2 times x minus 3 becomes equals to 0. Remember from one of the previous problems, the factors, if I'm able to write down something like this, x minus alpha and x minus beta is equals to 0, then alpha and beta are the roots of the quadratic equation, right? So alpha and beta becomes the roots of this quadratic. Of which quadratic equation is it going to be the roots of? When I multiply this, when I multiply this, you're going to get x squared minus of alpha plus beta times x plus alpha beta is equals to 0. So in this case, alpha and beta are the roots. Okay, so in a way, if I have a look at this now, which is nothing but x minus alpha equals to 2 and x minus beta equals to 2 is equals to 0. Therefore, we already know the roots. So, but geometrically, what do we understand from the roots? Roots are those values where the curve intersects the x-axis. Okay, so if I have a graph like that, x plus and y plus, that means x is equal, alpha is equals to 2. That means alpha equals to 2 and beta is equals to 2. Beta equals to 3. Alpha is okay, not writing. Let me refresh. Okay, so alpha is 2 and beta is 3. Means at a value of alpha, at a value of x is equals to 2 and at a value of x is equals to 3. Okay, so x is equals to 2 and x is equals to 3. So these are the 2 points where the parabola intersects the x-axis. We are not really sure whether the parabola is like that or whether the parabola is like that. So let's have a look at positive values of x. Does this equation give us the positive values of y? Okay, does this equation behave so? Let's have a look. Not necessarily, isn't it? But let's try and see what is going to happen at a value of x lesser than 2. Okay, what is going to happen to this at x less than 2? That means I'm looking at this domain at x less than 2. Say x is equals to 1. So at x is equals to 1, y is positive. So y is positive, right? So have a look at this. 1 minus 2 is going to be minus 1. 1 minus 3 is going to be minus 2. Minus 1 times minus 2 is going to be plus 2. So therefore, y is on this side. So obviously, the parabola is looking like that. So that's how the parabola is, right? Okay, so because we have already found out that what is happening in this, so if this is, there's no need to find out what happens after 3, because obviously it has to be a parabola. It cannot go like that, because then in which case it can never be a parabola. So we respect these definitions and then go ahead. So let's have a look at these 2 points. We have found out the points of intersection with the x-axis, isn't it? So the points of intersections with the x-axis are 2, 0 and 3, 0. Very, very simple. We did not even solve the problem using simultaneous equation or substitution method, right? So the problems are, the solutions are with the x-axis, the points of intersection are 2, 0 and 3, 0. Now let's see whether it actually intersects with the y-axis or not. Now, is there any value of y for which x can become equals to 0? Okay, in which case, if I do substitute the value of x becoming equals to 0 at x is equals to 0, what's going to happen to y? So y is going to be 0 minus 2 and 0 minus 3, which is going to be, y is going to be plus 6. Okay, so plus 6. So that means that this parabola is going to go and touch this y-axis at an intercept of 6. That means that the coordinate for this is 0, 6, because x-axis is 0. Okay. Means that the coordinates of this point are 0, 6. There we have it. So the with y axis is going to be 0, 6. Okay, we have found out the solution. I want to take you forward in one more step than what has been asked. The point where this the parabola turns is called as the turning point. Okay, let's turning point, and I'm going to find out what is that point exactly. Okay, that point can be found out pretty easily. So let's take the average of the two locations, because the parabola is symmetric about this line. It is symmetric about this line. So this point, the location on the x-axis must be an average of 2 and 3. So 2 plus 3 by 2, which is 5 by 2, which is 2.5. So the point here, the turning point, is then 2.5 comma something, and I don't really know what that y-axis is. Let me find that out when I do substitute that equation into this original equation of the parabola. I'm going to get y is equals to x minus 2, which is x is 2.5 minus 2, okay, multiplied by 2.5 minus 3, which is 0.5 multiplied by minus 0.5, which is minus 0.25. So this is having at a point of minus 0.25. Wonderful, fantastic. So the point of intersection, or the turning point for us, is 2.5 comma minus 0.25. There we have it. We have the solution to this problem. Do practice more problems like this, and I'll see you in the next video. Okay.